This is the second video in my new Money Button vlog series here, where I'm going to talk about things related to Bitcoin Cash, cryptocurrency, blockchain, and of course the Money Button itself. So the current plan is we're going to launch the Money Button on August 20th. I still think that's pretty realistic, but we have a whole lot of work to do. Of course, if you go visit moneybutton.com, you can see that we have a working prototype of it. We're doing a lot of things to make it much better. So basically, we started working with a design firm to redo the design work because we wanted the user experience to be, really professional and friendly for normal people. The idea here is that the Money Button is going to be something that, can be placed on websites and apps. And the idea is that it's the money button of the internet, that this is the button that you press to send small payments on the internet, probably primarily for content, but also for lots of innovative things that maybe aren't even currently done, things that like what we do on yours.org with new payment models that really require low-cost transactions. So when we started working with this design firm, we realized this process would take a while. So we realized that, well, gosh, we have a number of other issues with the wallet and with our software and technology that we should also go ahead and fix some of that stuff. So when we launch with the new infrastructure on August 20th, we have a brand new wallet. And you can thank Emilio for figuring out how to basically do this in a sort of scalable and private way. So the wallet is dramatically improved from yours.org in a number of ways, including we have multi-address support, so the privacy is much better. We also have designed all the architecture to scale up to tens of millions of users if necessary, because we have a number of prospective business partners that actually would have tens of millions of users if we actually integrated with them, and it seems like we have a shot at being able to integrate with partners like that. So we needed to make sure that the infrastructure would actually scale, and I guess that's basically it. So it's a brand new wallet that's actually scalable. And one of the sort of properties of this, like if you look at how other wallets work, we're actually solving some problems that actually aren't solved in some of the other wallets. So our wallet will actually handle a huge number of addresses per wallet. So you could have tens of thousands of addresses if necessary, and everything should work smoothly. So anyway, I'll talk more about that sort of in the future and in the coming weeks and months here as we lead up towards this new launch of the Money Button and afterwards. What I want to talk about right now, though, is a little bit more on ZeroConf, because ZeroConf is something we take very seriously. We think it's really important that you can send transactions instantly, and that from an end user point of view, that's it. That you don't really have to worry about this too much, that you can simply send and receive money instantly, and it works almost all the time. You can do this right now on Bitcoin Cash. However, there are a number of problems. Like there are ways to exploit ZeroConf, because if the transaction is not confirmed yet, you don't have this wonderful consensus mechanism built into Bitcoin Cash based on proof of work and all that stuff. So there's a proposal by Tom Harding called Superstandard immediate transactions. And I read through this, and Tom pointed me to this because it's obviously very relevant for Money Button and for yours.org. And I will say that, so I want to try and explain some of it, but I can't fully explain it because I don't get all the motivation. And Tom, if you watch this video, I think there's probably like a missing paragraph here that motivates some of the decisions made here because it's very unclear. Although this is written like a spec, maybe the motivation is supposed to happen somewhere else. But I feel like it would be helpful if there were basically just explaining, like there's that whole section here called motivation, but I still don't fully understand some of the decisions made in here. So let me just first of all, at a high level, the idea here is to create a class of transaction that's called Superstandard immediate transactions. And if transactions sort of satisfy the criteria to be a Superstandard immediate transaction, then you can rely on them with a great level of confidence. The consequence, or there are a number of consequences, but one of them is that there's a statement here, so non-SI payments become unreliable until confirmed. So this is one of the downsides. So this sounds like a reasonable proposal to improve ZeroConf in some cases. However, there are some unfortunate sort of downsides. So first of all, the upside is that if we can do this for real, that's great, because it definitely allows us to improve the reliability of ZeroConf in these special cases. But I want to go over the downsides, because the downsides are also very relevant here. So one of the downsides is that it spends exactly one UTXO, which must be confirmed. That's a significant drawback because on basically every wallet, you normally spend multiple UTXOs at the same time. So the only way to be always spending one UTXO would be like basically you put all your money in one UTXO, which means your privacy is a lot limited. So this, unfortunately, this just wouldn't work a lot of the time. I mean, sometimes you need to combine multiple UTXOs to spend, to spend money. However, I guess in theory you could combine this with merge avoidance. So maybe that's a way to improve this. Like maybe instead of spending one transaction that merges multiple UTXOs, maybe you just spend several of them at the same time, all of which are super standard immediate transactions. So maybe that's actually not such a drawback if we can also, basically have better support for merge avoidance in wallets and merchants and whatnot. Okay, so another drawback is no larger than 2,000 bytes. That's not a huge deal if you're only spending one UTXO anyway. I don't know why your transaction would be really big, but still that is a drawback. Also, there's a condition in here about setting a sequence number, which forces there to be a lock time. And then Tom gave me a clarifying comment that maybe this is actually not necessary, so maybe he'll be able to improve the protocol. So I think this is I look at this as being like a serious proposal for how we can improve zeroconf in the future. I'm not convinced based on what I'm reading in this document that this is the way for one primary reason. It is way better if we can find a way to do more reliable zeroconf that allows every transaction to be qualified. Like the fact that this creates a class of transactions is kind of annoying. Like it'd be way better if we could always rely on this always, and that seems like something that's just not possible with the way that this is designed. So we'll sort of see how this plays out. There's one property of zeroconf, like so with yours.org, we're actually not tracking the number of double spends. I actually don't know how often double spends occur on yours.org. We actually have no known case of it ever occurring, so it's possible it's zero, but it's also possible it's happened and we just don't actually know about it. With the new Money Button wallet, we'll actually be tracking this, so at least we'll be able to have statistics on how often double spends occur, because that's a critical missing piece here. We actually don't even know how often they're actually occurring, and we'll actually be able to tell in the future. Okay, so that's all I want to say about zeroconf today. I also want to mention just this morning, Jason Dreyzehner of BitPay published some cool work here on using Webassembly for faster cryptography in web browsers for like sort of Bitcoin crypto. So he has SHA-256, SHA-512, SHA-1, RIPE-MD-160 using Webassembly. And this allows you to do these hash functions much faster than you can do in pure JavaScript. So this is an important step forward, I think, for basically improving the usability of every JavaScript-based wallet. We're probably going to be using WebAssembly in the future for JavaScript stuff. And WebAssembly is basically achieving the original vision of Java for people who are clued into the history of programming languages and stuff. WebAssembly might actually achieve the mission that Java was supposed to achieve in the 1990s, which is basically this sort of bytecode for everything. So this is pretty exciting, and we're not going to use this right now just because there's no reason for us to be super optimized yet. However, I'll sort of keep this around, and as soon as we need to optimize hash functions, we'll use this. And I told Jason, in fact, I created an issue on his GitHub repository to add support for bcrypt because it'd be really useful to do client-side bcrypt for reasons that I maybe will explain some other time. So that's all I have for today, and I'm going to keep creating videos about the money button and all issues around the money button. It won't be entirely technical. I'm going to talk about some other stuff like the marketing, branding, and whatever other business things as well. But it'll probably be more than 50% technical. Because I think this stuff is sort of the most interesting, the most important, as well as the stuff that I can talk about sort of in a way that's like actually useful to people. So thank you for watching.